A very good afternoon to all of you. I am Ella, welcoming you all on behalf of Solar Quarter and the First View Group to Empowering India's Energy Revolution with Storage Tech webinar. Before we proceed further, I would like to thank our panel members for their immense support that has led to the organization of this event. Their commitment to promoting energy storage solutions is truly commendable and will empower India's energy revolution. And to our audience today, thank you all for joining us from all around the country to delve into the storage landscape in India. All of you are welcome to post your questions in the Q&A box during the discussion, and our speakers will answer those questions at the end of the discussion. India has embarked on an ambitious journey towards a sustainable energy future, increasingly leaning towards renewable sources. The country has seen remarkable growth in renewable energy infrastructure, harnessing solar, wind, hydro, and bioenergy resources. Energy storage technologies, with their ability to provide grid management services, would play a critical role in India's energy transition. The Central Electricity Authority has projected a requirement of 74 gigawatts and 411 gigawatt hours of energy storage capacity by 2032. Various policies and interventions. Storage technologies such as lithium ion batteries, pumped hydro, and bioenergy are being explored to tackle intermittency issues of renewable sources and meet the country's rising energy demand. This focus on energy storage reflects India's commitment to curbing carbon emissions and fostering a sustainable energy landscape for future generations. This webinar will serve as a platform for industry leaders, policymakers, innovators, and stakeholders to come together and explore the dynamic changes occurring in the energy storage landscape. Our goal is to foster a deeper understanding of the opportunities and challenges that are serving this energy revolution. So, without further ado, please allow me to introduce you to our esteemed speakers today. Mr. S.N. Tripathi, Regional Executive Director, Hydro, and Executive Director, Project Management, NTPC Limited. Mr. Abhishek Ranjan, Senior VP, Strategy and Head Renew Power. And we also would like to welcome Mr. Anil Surajkar, Strategy Officer, Meteorology and Environment, NTPC. Over to you, sir. Over to you, Mr. Tripathi, Mr. Ranjan,
Yes.
and Mr.
Good afternoon. Good afternoon, my dear panelist Abhishek, Kritika, Ala, and all who are connected online. And we hope this 1 hour session uh, will be very fruitful and objective. The today's discussion points, the storage, which is the need of the hour, and what first of all I want to introduce myself. Already a small introduction has been given. That is, I am SN Tripathi, and I am heading the project management team at NTPC. And also, I am regional executive director for the complete hydro, including pump storage project in NTPC. And I have got around 38-year experience in various capacities in NTPC, only in operation, maintenance, and commissioning, as well as the project execution. I was head of the project of three plants of bigger plant of NTPC, and then finally I am in the project management and heading this portfolio. Now, I think the topic and the requirement is quite relevant. I hope Mr. Abhishek should give his introduction. Then we can interact. Okay.
Yeah, sure. Thank you, Mr. Tripathi. I think we have another colleague of ours, Mr. Anil Suradkar, and welcome, Mr.
Oh
Anil.
yeah.
Yes, yeah.
Oh.
Yeah, so my name is Abhishek, so currently working as Senior VP of Strategy and Operations at Renew, and focusing mostly on energy modeling, RE forecasting, including storage modeling. That is my current area of work. But whatever I speak over here will naturally be a kind of views are personal to me. That's what I want to declare over here, not a view of my organization, current or past. Now, prior to this, I had also an experience of implementing battery energy storage at distribution transformer level in my previous company, in a discom in Delhi, for example. So we'll be talking more about the energy storage landscape, as Mr. Tripathi has spoken about, and we'll talk about the various aspects of energy storage, technology-wise, application-wise, policies, also about the grid integration aspects, and we'll see what are the prospects vis-a-vis CA's optimal fuel mix report version 2.0 for how much storage is going to be there by 2030 or 2032, and why is it important. We'll see those aspects and also compare and contrast. But before we start, maybe I'll also request Mr. Anil to come in and give say a few words.
Yeah, so thank you so much, Solar Quarter, for organizing this particular event. Thank you, Mr. Tripathi, and thank you, Mr. Ranjan, for your introduction. So, myself, Anil from Surya actually, I'm heading strategy and business development part in Surya right now. And basically, we provide online monitoring and controlling solution to solar companies in India and outside. And energy is something which is going to be another added component for monitoring. So that's where it is going to be a very interesting topic for me also to discuss further.
Thank you. Uh, Thank you. I think Mr. Ranjan has already set a tone, a line that regarding energy storage. I think the whoever attending this webinar, they all are clear that as we are growing, our GDP is growing, and the energy intensity of the electricity, that is electrically energy intensity towards the growth, is also increasing. Moreover, our sensitivity to the environmental concern and the many commitments made by our government at various COP requires a lot of renewable capacity which is required to be added. As far as today, around 14% of the renewable power in terms of energy generated is being contributed by renewable part. Rest are fossil fuel. But we are having a very, very immense courageous plan by the government. By 2030, 50% of our capacity will be from non-fossil fuels. And in this context, more and more renewable capacity which is going to be added. I think everybody knows the renewable, that is wind, except hydro, wind and solar, is having certain limitation that it is time variant, location variant, and that virtually adding a flexibility to the grid. And finally, there is a gap between the peak generation and peak demand, as well as the off-peak demand. So previously, we were operating the grid with a fossil fuel, and where we all were operating in a very flat curve. Now the curve is changing. So in order to fill the curve and in order to make it a straight line, the storage technology is very, very important. I think when there was power cut in India earlier, we used to operate with DG or battery inside our houses in order to conceive our demand. Uh, the distribution companies were virtually owning some of the pump storage which were available in the country in order to meet their peak demand. Now, as long as we are in plan to add more and more renewable, the need of more and more storage has come out, as in the introduction part, and Mr. Abhishek has also told about the 74 gigawatt of storage will be required as per the CA projection by 2032. Even in next 3 years, we will requiring around 16.3 gigawatt of storage, which is virtually as per CA prediction, around 7.45 will come from pump storage and 8.68 through battery storage. It is a projection given, very short term projection by 2027. So, in this context, the various options available for the storage and the challenges need to be deliberated with the technocrats. So, virtually, it has got three aspects. One aspect, the technical viability, techno-economics. Second is the challenge in development in the country like India, which is virtually the power 10-year, 15-year back was not a virtually this item, even we were able to withstand certain power cuts. Now it is an essential item, and our country is growing very fast. So we need more and more power, more and more energy. We cannot tolerate the power cut or loss of any production because of the electricity. So storage will become very, very important. So hope with this background, I will request my other panel member Abhishek Ranjan to say about the context of requirement of storage and present scenario in the storage system.
Sure.
Over
Thanks a
to
lot, Mr. Tripathi. Yeah, thank you. So, as correctly said, the introduction to energy storage and the landscape in the country today. We see today we are above 425, 426 gigawatt of installed capacity, out of which about solar and wind comprise of about 120 plus gigawatt. Battery storage, if we talk about the battery energy storage, is virtually nil. Whereas we do have a couple of pump storage plants which are already operating in our country, which I think Mr. Tripathi will speak about later on. Now, you see the share of fossil fuel, that is coal and gas, in terms of installed capacity as well as energy, is very, very high in country today. So out of that 425, 426 gigawatt of installed capacity, almost say 56, 57% is coal, and 5 or 7% would be about gas, right? So if you talk in energy terms, so energy terms today, the total fossil, that is gas plus coal, is about 60% in energy terms. And as Mr. Tripathi talked about, if you include a large hydro to the solar and wind, the share is about say 14-15% in terms of energy. Now, as per the CA's report of optimal fuel mix by 2030, it envisages that our installed capacity will go up to about say 800 gigawatt, that is 777 gigawatt, and about 74 gigawatt of battery storage by 2032, which is about 42 gigawatt in 2030 as per the report. 18 gigawatt of pump storage is also envisaged to be on bar by 2030. Now, in energy terms, the share of renewable energy in the overall mix is expected to be about 35-36% in terms of solar and wind only. If you add up hydro, it will go up to about 40%, 44%. So you see, in energy terms, the share is growing very, very high. And as we grow in the terms of renewable energy share, which is, we all know that they are all very intermittent and variable, we need flexibility on the grid. And storage is now the need of the hour. Earlier, the storage, as Mr. Tripathi also spoke about, was needed for ensuring reliable power supply whenever there was a power cut as a UPS. But now the storage is going to be used majorly as an ancillary service to provide reliable supply to support the renewable energy intermittency and variability. A. B. Used in the energy PPA to create load following RE based, 100% RE based profile. So when you say RE based profile, base load, peak load, intermediate load in RTC profile to be provided by the renewable energy, and that's where the storage plays a very important role. Now, the different kinds and technology of storage with different duration, be it a short duration, maybe lithium ion, which is 2 hour to 4 hour, or pump storage, maybe 6 hour to 8 hours, or maybe long duration energy storage, maybe vanadium redox, or maybe liquid air, which may be of 10-15 hours plus. So would be required as we go deep dive into more and more renewable share in the overall energy mix. So that is going to foresee a next level of challenges. So we see that there is a need for renewable energy both for the ancillary and the energy supplies, and for providing renewable energy as a base load as well as complete RTC profile. Apart from that, the variability of the renewable energy at the point of common coupling, wherever the RE, that is wind and solar plants, are getting connected with the grid, at that point of time, you have to provide a reliable declared schedule basically. Now, the Grid Code of India, which has been enacted recently and came into effect from 1st October this year only, 2023, it talks about many revolutionary changes. One of them is the primary support to be provided by renewable energy stations themselves, which means that the solar and wind has to respond to any change in the grid frequency more than zero point 0.3 hertz by ramping up or down their output up to plus minus 10% of the maximum AC rating. Right now, this also requires intervention of storage or maybe inverter themselves. So that becomes an ancillary support by the renewable energy sources themselves, where storage is going to play. And here the storage would be a high capacity or high power. So we'll deep dive into the various use cases, regulatory and all in the next. But before that, maybe I'll invite Mr. Anil to throw some light on his perspective on the energy storage landscape in the country, especially since he's dealing into the monitoring system of rooftop solar and solar as a whole. So maybe what role does he see the role of storage over there? Over to you, Mr. Anil.
Yeah, thank you. Thank you for setting up the tone. And I've been there in the industry for 15 plus years, and initially, solar, as you said, was used only for powering fuel stations or petrol pumps. And that was the starting point, and the largest solar power plant was to the tune of 10 megawatt. As we have seen in entire energy mix, the contribution of solar and wind has increased enormous. So with that addition of renewables, definitely, as rightly initially Mr. Tripathi said, that there is no firm power of wind and solar, because there is a wind will only give power when there is a wind flow, and the solar is going to give in the daytime. So we have to monitor this particular energy, and then based on that we have to adjust the battery sizes. We have to and this is not going to be there only for one particular solar power plant. We could see the requirement of these customers, those who have installed even a rooftop, those who have installed solar power plant maybe 2 or 3 years before. They are also talking about the energy storage because of the sometimes load fluctuation, or in order to balance the things. I think it's a matter of few more years or few more months, I would say, once the economy is of skill and the technology proven. So everybody, those who have already also gone for solar power plant or renewables for any extent, the people will start putting the batteries in their respective devices. And along with that, we are also seeing the tenders which are coming as a RTC. Like, and in all the tenders, we will find the mixture of wind plus solar plus battery. So that kind of trend has already started.
Okay.
Yeah.
Yes,
Or
thanks,
Okay.
Mr. Anil. Mr. Tripathi, maybe may I
Yes.
request you to come on board and throw some light on
Yes.
your
Yes.
rich
Yes.
PSP experience,
Actually,
basically. We'll talk about more about the PSP.
in order to continue the further discussion, as it has emerged that more and more renewable will be added, so more and more storage will be required. Currently, the projection of 74 gigawatt, but the development of storage system, virtually there are certain technical parameters which decides the effectiveness of the storage, like the energy efficiency, power to energy ratio, useful life, depth of discharge, and energy density. These all are the technical terms that is normally considered in order to select the energy storage devices. But this energy transition that it is taking place in the country, and the particular storage system, it has got very high cost involved. So first of all, I want to touch upon the uh, the capex which will be required in order to develop the storage system. So as per the present projection, by next 4 years, we will require 1 lakh crores of investment, in which 54,000 crore will be required for the development of pump storage, and 56,000 crores approximately will be required for the development of BESS, that is battery energy storage system. Similarly, for next 5 year, another 3.68 lakh crore. So huge investment is required. Now, what is happening? I think last year there was a discussion in Ministry of Power, and in which CA organized a meeting in which we discussed about the viability, how this will be commercially viable. Many policies were added in 2022, and finally in April, while declaring pump storage policy in 2023, something about the commercial aspects was also added. We are Government is actively considering the viability gap funding for small time period, as well as I think allowing ISTS free ISTS connectivity for a limited period for pump storage as well as other storage system when it is going to come. So as a part of the policy perspective, government is thinking very actively to support the developers. Even the some PLI scheme is also being thought of to be added for the production of storage system in our country. But as Mr. Abhishek has told, I will start the pump storage system. The technology-wise, pump storage is not a new technology. I think it was way back in 1890 when the pump storage, we were in engineering graduation, we also thinking in the hydraulics book, the pump storage, that is upper reservoir and lower reservoir and the pump and reversible turbine and pump technology. So it was on the world perspective, it is a very simple technology that was available. But as you know, when there was a flattened curve, means the base load power plants were operating, there was no difference in the tariff of peak hour and off peak hour. Then commercially viability of this pump storage was not possible because of the efficiency rating of around 76%. So who will like to lose 24% of the power of generating electricity? But what happened, so that's why initial days in 60s, 65, then 70 and 80s, some of the pump storage projects were developed in our country, and Andhra Pradesh as well as the West Bengal were pioneer in development of this. Sri Salam and then Purulia, these all were developed. But the right purpose of development of this pump storage was not as a storage with integration. Virtually, it was just to meet the peaking demand. And if you observe the operation of Purulia pump storage, where I was actively, virtually I have studied, there are average around 9 to 10 startup daily, means 9 times they are starting the pump storage and then stopped because of fluctuation in the grid. They are just adding extra power whenever there is a need. The West Bengal government is not buying power from the market, they are using their pump storage. So it is being used as a filler. But what pump storage now we are designing a higher capacity pump storage which will be operate commercially, maybe in single cycle or double cycle, whatever may be the mode, in order to fulfill the RTC requirement of the renewable. So whenever we are going for RTC and pump storage is going to add the responsibility and the response of the pump storage is very, very important. So now while so as far as the pump storage is concerned, technology, there are, I don't think there is a challenge in the technology. Everybody in the world is providing similar type of technology, as well as only variation of 2 to 3% variation in the efficiency portion presently. So whoever 4 to 5 manufacturers to whom we are virtually in constant touch. Uh, as I told, whatever view I am expressing, it is not my company view. It is my totally personal and my experience view. So as far as the NTPC is concerned, we are on verge of virtually in the final stage of development of around 11,000 megawatt of pump storage at various locations in Tamil Nadu, Tamil Nadu, Maharashtra, in Himachal Pradesh, of course, and then Karnataka also we are very actively pursuing the getting. So soon, I think within 1 month, we will be announcing the start of the 3,000 megawatt very soon. So the first part is the technical part. There is no challenge. Second part is the execution part. You know, the hydro as a whole is being executed in a very long time because of this terrain on which it has to work. Now the requirement is changing very fast. So we need a storage in 2 to 3 years or 4 years maximum. So by 2027, we need good ample amount of storage. So the faster development is required. That's why CA wise, while giving its means guideline in the pump storage, they have fixed the timeline for DPR, and then finally they are allowing quicker resolution, techno-economic clearance, and everything. They have begun a timeline. Even I have requested chairperson CA, if required from industry side, we will put some additional manpower there to support CA in order to get everything set right in a, because usually this DPR business earlier used to take 4 years, 3 years to 4 years. Now, if 4 years is required to plan, where will be my implementation period? Government wants the PSP to be developed in 4 years. Now, this 4 years development will be very, very tough for anything. Of course, when DPR is approved, after that 3 years, 3.5 years execution period is quite okay. We can do, provided we get something which is very, very means it is very common that 4 years period we can develop the pump storage. So my store in the pump storage part, the DPR preparation. So how to prepare the faster DPR? It is very, very important, because lot of technology has been added. Because in India, our GSI and the CWC all are giving the technical input to the guideline for the DPR, but technology has improved. That's why we are proposing a very advanced method of putting actually preparing the DPR. Of course, there are certain policy guidelines. The data required for the annual variation is a part of requirement. The second aspect is the challenge that we are facing in execution of the hydro project. The same will come in the pump storage also. So that's why the geological survey is very, very important in order to eliminate the surprises. And finally, which is virtually affecting the execution in terms of disputes with the contractor. So good contracting system, good DPR will give a good execution, very shorter execution time for the pump storage. So without taking much of time, the pump storage development as per the policy given by the government of India, even if the self-chosen choosed sites are also being allowed as per the policy, and it is being developed, and many states have come up their own pump storage policy. So the next 1 year is very, very important after getting the policy of each and every state, and then the technical aspects of making DPR and having good contract, written contracts in order to address every challenge in the execution is the real part which will play a major role in deciding the future of the pump storage. As far as the
Sure.
government is concerned, our ministry is very, very clear, very, very focused that it should be developed. Desire is there, but there are two things. Whatever challenges I have told, and the second challenge is the money. Of course, the viability gap funding is being asked from the developer, but the green capital raising as well as this development is required a lot of money in this. And it will require 4 to 5 year period in which the pump storage will virtually to help. Then after 5 year, what will be the fate of the total energy scenario? Of course, projection is there, but developers are also moving in a very cautious manner in the development of storage. So that is the point I wanted to deliberate.
Thank you,
Thank
Mr. Tripathi. Yeah, so
you.
as rightly said,
Yes,
in the space of the pump storage, the government of India has come out with the PSP policy very recently and this year only, and then several other states, including Madhya Pradesh, have come out with their respective PSP policy. And very recently, last month, Madhya Pradesh Power Management Company Limited, which is the procurer for the state of Madhya Pradesh, they have floated a tender for 500 megawatt 6-hour pump storage to be located anywhere in India. And interestingly, what new thing has happened is earlier when Karnataka floated a tender, the time period given was 3 years from the signing of the PSP agreement signed, the commission date. But now in the MP tender, they have given 72 months, which is 6 years from the date of signing of the agreement, that is pump storage agreement. Now, so it is now being seen practically that, yeah, so for any greenfield pump storage, probably 5 to 6 years, as Mr. Tripathi said, is very much required from concept to commissioning. And especially the off the river configurations are much preferred one because they are less disruption to the flow of the river. And therefore, there are many sites in the country, including Odisha, Maharashtra, Madhya Pradesh, Rajasthan, and where such sites are being found out, which are off the river and where maybe either one of the reservoirs are being already in place, so that it shortens the duration for, And then in the policy also, the government has clarified many issues. For example, how the input cost or to pump up the water up to the head pool would be treated. For example, in the MP tender, it has been said that it will be given as a free entity from the procurer of the, so that is not to be burdened on the tariff of the particular. Number one. Number two, the tariff to be determined for a storage is based upon capacity, not in rupees per unit terms, and that is a very good development. So you talk about rupees per megawatt capacity per annum. That is the kind of tariff which is to be quoted. And of course, there has to be a total storage cost as per this tender. So inclusive of the cyclic losses, which Mr. Tripathi talked about 24 to 25%. So now coming to the innovations in the battery technologies, apart from the pump storage, the battery technologies, mostly we have, which are thermally more stable, are lithium ion technologies. So lithium LFP batteries are more stable, and they have been talked about in both in mobility space as well as stationary storage. And one country in the globe is controlling most of the supply chains, but thanks to the India's Advanced Chemistry Cell PLI scheme, the capacity for putting up and assembling battery storage within the country is now in place. Some of them are already under construction, and the capacities are getting built up. Now, the point is, why to be reliant upon only a single technology? So therefore, you talk about other technologies, other chemistries, for example, zinc, sodium ion, or even the flow batteries like vanadium redox, which is one of the most commercially advanced. In fact, I know personally few of the installations in India which are manufacturing kilowatt hour scale vanadium redox batteries, which are being exported, commercial grade. So in terms of flow batteries, but then coming to the scale, a large scale, for example, when you talk about the megawatt scale, for example, the first peak power tender in India, 300 megawatt with battery storage, ReNew is installing a battery storage, which is lithium ion in the state of Karnataka. And we'll possibly see the commissioning. I think the storage has already been installed. The commissioning is underway. That will be a first megawatt scale battery storage, utility scale in the country, when it is commissioned. So commercially, the lithium-ion technology is viable, commercially deployable. The costs are also coming down. For example, as per the BNE projection, the cost currently is about $300 per kilowatt hour complete installed cost. Now, due to recent geopolitical changes and the glut in the supply, due to the Chinese oversupply scenario, even there are more competitive prices being discovered in some of the recent tenders that we have seen. Now, apart from that, there is a limitation with the lithium ion. It's maybe viable only up to technically only up to 4 hours. But going forward, we also need long duration storage, so longer duration storage. So for example, even in intraday scenario, pump storage might be there for serving, say, evening load. So starting maybe 6 p.m. in the evening or 7 p.m. in the evening till say 1 a.m., which is the peak demand period, especially in summers in India, northern India, basically. So at that point in time, the storage is longer duration like pump storage or even longer, maybe 12 to 15 hours also will be required going ahead when we replace coal slowly as a base load. So when you talk about innovations in the battery technology, so one is liquid electrolyte. Today, what we're talking about, another is solid state batteries. So Japanese are ahead and they are experimenting a lot in the solid state electrolyte based batteries, and possibly we'll see some of them commercially being rolled out towards the turn of this decade, maybe next 3 4 years, and they are expected to be much cheaper and more reliable compared to the current liquid-based electrolyte-based battery. So those advancements are happening, and of course, as I talked about other chemistries like zinc and sodium, and even in electric mobility, aluminum air is one technology which one of the companies I know they are working a lot on that kind of technology. So good point is in electrochemical batteries, the electric mobility supply chain and for the stationary battery storage applications both have the same kind of source. So uptake in the electric mobility also has an impact on bringing down the overall cost of the batteries cost for the stationary purposes. So that is the best part of it, and we expect that the as per the Bloomberg projections, next 2 to 3 years, the battery costs are going to dip below $200 a kilowatt hour, and which is a sweet spot for the utilities to have a very comfortable round the clock, even at today's prices. The round the clock renewable energy prices or cost completely 100% renewable is very, very low. So now I'll invite Mr. Anil to throw some light. You would like to, I mean, in rooftop solar, what do you see the role of the battery storage? Do you see that smaller battery kits, which can be provided and clubbed with the rooftop solar, can make an impact on the overall demand and thereby also optimize the need for a larger utility scale battery storage at a larger scale?
Yeah, so there are two to three aspects to this, what you have shared. One aspect is that already the rooftop, the solar which is going in CNI market, like commercial and industrial, these people are planning already to install a solar power plant. And with the regulations like SLDC, CLDC, they are asking the, to reduce the solar power plant, which are on an open access side. So sometimes they are asking to reduce the electricity generation. So these kind of methods are coming, and because of that, people are realizing the importance of storage in a way, especially if when it is the storage at the plant level. And as you rightly said that when the batteries are going to go in electric vehicle on a higher side, definitely in a year or two the prices are going to reduce further. And I think that was the moment wherein everybody will try to pick, and they will install this storage in their in their plants. So that's what I could see. And along with that, I think the policies are also getting favorable to this. Adding to this is like we in Jammu Kashmir or in Rajasthan and in Karnataka, some of the areas. In India, we have found some reserves of lithium ion, so that is also an added advantage for India, I think. And I think we missed one part when the solar panel, it got launched. At that time, we were not that aggressive, but I think at this particular particular juncture, I could see even the government is very aggressive in terms of taking the battery, at least lithium and battery, into mainstream very fast as compared to the solar panels.
Yeah,
Okay.
thank you, Mr. Anil. So now let's turn towards something very important and which is very dear to me as well: grid integration of the renewables and what is the role the storage is going to play. So may I request Mr. Tripathi to throw some light because you are the largest power producer in the country and you know the best what you mean by grid integration, not only of the coal-based plants as well as renewable. So what do you think the role of storage is there in the grid integration of renewable energy in the country?
Thank you, Abhishek. I think you have rightly told. The grid integration is very, very important aspect. I think during our earlier days, how this grid was used to be operated. I have seen the frequency variation from 47.5 to 51.2 hertz many times. And in fact, I was the head of operation many years. And we used to have in Madhya Pradesh, and you used to have 3 to 4 blackouts in a day because of various reasons. Now, as our grids become bigger and bigger, the more integration has come in terms of geography of the country, means inter-state grids were combined, and the grid size, that is the power number of the grid, has increased, and the stability has come. With the many improvement in the either will be ability based tariff and what the present tariff is concerned, and the grid controls, the frequency regime has now come to a very, very respectable level of variation that it was used to be here. When I have went to UK, I have seen in the CGB panel very small variation in the frequency. So now with more and more renewable we are going to add, the stability of the grid is very, 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 very important. And the role of storage in the integrating the grid, that is grid integration with more solar, wind, and everything on a single, grid. It is being fed from different sources with more and more variations. There must be some absorber type of thing. The another aspect that this pump storage and other things, and any device is concerned, the need of the reactive power. The biggest disadvantage of this solar power is it is non-reactive in nature, and most of the our industry load, and you all know, is requiring the reactive power. That's why many people are working on the condenser system. That is very important aspect that is going to be developed in order to renewable. So virtually we are also thinking, it is in my plan, whenever I am retiring my thermal power, its generator will be used as a synchronous condenser in order to give the stability to the grid. And I think the time will come when we will be charging on the MVR also. So now megawatt is charged, megawatt hour, kilowatt hour is charged. Now the MVR will be charged because of the demand. Now it is integrated with the system. We are not giving pinch, but I am just guessing in 5 to 10 years, when more than 100 gigawatt is added, there will be requirement of reactive power, and more storage system are required to be integrated with the grid, so that stability can be achieved in terms of the requirement of the customer as well as the stability of the grid. Otherwise, many of the our system of the supply, the grid has been designed not to withstand such type of scenario in which instability of different equipment transformer will come and there will be power outages. So integration is very, very important with the storage. And of course, I am talking about the bigger grid, because Mr. Abhishek said told we are operating in a very large scale, 75,000 megawatt of operation that we are doing. But the integration of the grid with, I think this solar and storage, even the concept of microgrid has also come in the local area grid there also, and integrating many microgrids is now coming to a very small distribution system which will be self-dependent, maybe RTC, more greener and something. So that concept may come. So now I'm handing over to Abhishek to have a more light on this.
Sure. So thanks a lot, sir. So grid integration, yes, we know. We talked about the reactive power support. Yes, that is very much there. And apart from that, the HVRT and LVRT, so low voltage right through and the high voltage right through, that is very important. Now, as far as grid integration is concerned, the moment we talk about grid integration, we the thought comes to us about what is called as ancillary services. Now, when you
Yes.
talk about ancillary services and ancillary reserves, the three classes of ancillary as per CERC Ancillary Services Regulation 2022, primary, secondary, and tertiary. Basically,
Yes.
they all are dependent upon the time taken for the response. Right?
Hmm.
So the faster one are primary, then secondary, tertiary. Now,
Yes.
battery storage, and for that matter, even the pump storage, they qualify for, I mean, the given the response time required as per the regulation as a primary reserve,
Yes.
and they have a very fast response time. In fact, as per a few of my colleagues and Mr. Tripathi may confirm that within a minute or less than a minute, maybe the guide when openings can be controlled from
Correct.
say a minimum load to the maximum. It
Correct.
can respond,
Yes.
and the batteries can also respond within a few seconds. So this is a very important attribute where the batteries are going to be used for ancillary when there is a sudden loss of generation or there is an over generation compared to demand, and therefore hence to control the frequency. So the enabling provisions are already there in IEGC regulations 2023, which came into effect from 1st October 2023, and also in the energy ancillary services regulations, as well as the resource adequacy guidelines, which have been floated by the Ministry of Power this year. So now coming to the energy storage policy and regulation, so it becomes very, very important. I remember 5 years ago when we were talking about a battery storage project, we were asked the question, what is the definition of the storage? Where is it defined? Whether in the Electricity Act, any regulation of CRC or SERC, any electricity policy, National Electricity Plan, where? To the irony, it was not defined anywhere. It was not defined anywhere in the any of the documents. But over the past 2 or 3 years, we have seen that vacuum being filled, starting with clarifications and amendments to the electricity rules, basically, and also the draft national electricity. Uh,
Plan.
One is NEP, National Electricity Plan, and then the draft NEP, National Electricity Policy. The storage has been defined, clearly defined by Ministry of Power. What do you mean by storage? They have, with repeated orders, different orders, they have clarified what could be the use cases of storage, whether at generation coupled, transmission, distribution, behind the meter, wherever it is, standalone. It is not a licensed activity. You don't have to take a license if at all you're going to install a standalone storage. And then different use cases have also been propagated. So, what are they? For example, tertiary reserve ancillary services based upon market. So where the storage is going to have a very important role. High price day ahead market, which is an energy market, where the storages can take a part directly, just like imported coal or gas based generation. Now, primary reserves, that is a mandate for RE stations. So there again, storage plays a very, very important role. So without storage, it will be very, very difficult to have that kind of response time to the primary. Of course, you need a smart inverter, and of course, you can have a choice, commercial choice between installing a smart inverter vis-a-vis adding a storage device to it. Now, the value stack, if you talk about in terms of battery stationary battery storage, one major is in the energy segment, which is energy arbitrage. So you can charge cheaper and discharge at a time when the grid power is costlier. That is a very basic and very important aspect of it. Second aspect is about using the same battery storage in high price DAM. So it is a part of the energy arbitrage only. Third is you are using it to deepen the green contribution in the grid. So that means You are charging the battery with greener surplus power in the solar hours, for example. And in evening hour, when the green content of the grid is low, you discharge the green power stored in the battery, and therefore overall carbon footprint of the power reduces. So that is very, very essential as we go forward. Fourth, a very important aspect what the government has talked about, Mr. Tripathi talked about, like possibility of viability gap funding for the pump storage. The government, its annual budget has already announced VGF for battery energy storage system up to 4 gigawatt hour. So one such tender, 500 megawatt, 1000 megawatt hour, was already conducted by SECI, where JSW is in a energy is the winner, and that is likely to get the benefit of this VGF, and 3 gigawatt hour more such capacities are going to be. There is a need to further incentivize, and lest I forget, there is a storage purchase obligation as well. So in our country, the Ministry of Power, Government of India has also laid out storage purchase obligations as a percentage of energy. So much energy has to be procured through storage devices. And of course, the storage has to be charged through green power. I think if I'm remembering correctly, up to 85-86% of the discharge should be charged with green power. So there are multiple initiatives which have been undertaken by the government to promote storage, both pump storage as well as battery energy storage. But many more things have to be done. For example, Energy Conservation Act has been amended this year, and the detailed procedure, it talks about every building in the country to procure certain quantum of its power from green sources. Every building, be it residential, official, commercial, industrial, whatever it is. And that is a very, very important aspect to reversionalize and introduce storage even at a distribution level. So, battery as a distributed energy resource to be installed at a transformer level or even at the CNI industries, in their factories, in their offices, replacing DG sets. So ban on the DG sets is also coming. So there is a very important aspect now, the commercial, some of the calculations that we have done. We find that the batteries are viable even at present day cost, given the myriad investments coming in. There are a lot many green investments, especially the long-term funds, pension funds, etc., who are interested in the India's RE growth. So, given the policy certainty and the firm resolution of the government of India to go green by suitable measures which are pointing in a single direction, that while we have to ensure energy security of the country, but there is no going back on our green commitment. Okay, so for example, one of them is 50% of our capacity should be fossil fuel free by 2030, and 500 gigawatt of RE capacity by 2030, and then commitments about carbon markets, voluntary carbon markets. So all these places, wherever we are talking about more green component, we will see a lot of policy changes. Having said that, at state level, for penetration of the battery storage at rooftop or distributed level, we need still more clarity in terms of regulations. So before I hand it over to Mr. Anil to talk about that aspect, what would be his wish list for regulatory changes as far as solar and batteries are concerned? I would just like to state that early this year, we together worked on a DSO roadmap, distributed system operator roadmap for the country, where the discoms need to transition to a DSO, and there the role of a storage is going to be paramount. Without storage, you can't be a DSO. So over to you, Mr. Anil, and what are your wish list in terms of policy and regulatory changes as far as distributed solar and battery storage is concerned? Thank you.
Yeah, so before touching to that particular point, I also wanted to share one thing that as the storage is coming in a role in most of the power plant, even a utility scale and open access project for CNI. So the requirement of PPC is increasing day by day. So that is power plant controller. So earlier we were only had to control the solar part, but now the requirement is also coming to us that they also wanted to control the battery related things, or whenever they wanted to curtail the generation. So the this particular amount of energy should go in the batteries. So that kind of requirement is coming, and that's where I think the policies are playing a major role, because earlier it was for 20 megawatt. If somebody is going for that or more than that, they were required to have a PPC. But now the changes has been done, and even 5 megawatt they are also requiring the PPC. So that kind of I think that kind of things are definitely defining the focus of government, and where exactly we are heading in terms of storage also. In If you as you asked me about the what's my wish or what's the requirement, I think this is going to be a ecosystem for everybody, and those who are there in this particular journey, be it into like battery manufacturer or integrator or developer or IPP. So everybody is going to get the benefit, because certain problems are beyond the you can say boundaries. So when we are talking about the green energy, so these are the things we have to come together, and then we have to fight on this particular aspect. So from Surya perspective, I think one more component will getting added, that is a battery storage, and we also need to monitor and control the battery storage in coming future.
Okay.
So thank you, Mr. Anil. I think we are nearing the time sanctioned to us, maybe a few
Yes,
minutes left.
yes,
What I'll request Mr. Tripathi is to throw some light on successful case studies very briefly,
yes, yes.
and your closing remarks in the next maybe
Yes,
minute. I think
yes,
Kala
yes,
is already here.
yes. I think how this 1 hour has gone, I cannot believe many things are left for discussion. Actually, before trying to have a few case study, of course, there are very limited. I want to tell there are certain policy interventions which is taking place very fastly in the country regarding storage. Like now, the government is thinking of energy storage obligations with all renewable, already given guideline. So every renewable will have integrated with the storage. So they will be compelled to do, and for that the viability gap funding and whatever it is required, maybe for manufacturer of storage they are giving PLIs, ISTS already I have told the free supply. So these all incentives are being given. But in the battery, there are challenges already explained by Mr. Abhishek. There are challenges. They are the technical challenges. But I want to throw some light that the next 10 year will be very challenging for the storage device development, because a lot of chemistry is now taking place. So now we are virtually this storage system, we are switching over the more chemical reaction type of thing. So new innovations are coming, maybe methane based, hydrogen battery, and everything is coming up very fast. And this may replace this conventional battery whatever we are thinking. So taking the total discussion apart from that, there are certain concerns with the storage system what we are trying to push, that is the store battery, that is the disposal of the entire battery. Suppose 76 gigawatt of the storage, suppose it is totally comes from the battery, how much of the volume, that is the area required for per kilowatt hour, if you calculate, it will be a great challenge, think in coming future for the disposal. That's why the government is also coming up with regulation from the supplier that they will buy back it to reuse. So from linear economy to circular economy, we are going through the reusing of the component. So that aspects also government is thinking, giving certain guideline. Regarding the case study, I think I have seen very closely this development of Purulia pump storage. Uh, Virtually, the site selection is very, very important in the pump storage. The entire life cycle, the execution cycle will depends upon the site. A good site will reduce the time by 1 year. Even rock conditions, position of the where you are putting your powerhouse, your water conductor system, how we are going to design. Nowadays pipe is being designed in terms of tunnel. So the Purulia pump storage, which was virtually developed, I think 15, 20 years back, and it is running constantly. The machine is supplied by Toshiba, and the main beauty of this pump storage is very very uh, efficient generator, because generator terminal and the power supply reversal, that is in case of generator, and the when it is acting as a pump drawing from grid, sudden switchover, and that at that time stability of the generator is very very important, and that has been done very beautifully by Toshiba. And the Toshiba team, when they come in India, they are coming very aggressively on the pump storage, especially the mechanical item supply. So the development of Purulia, as well as in the Tehri, which is the TSDC 1000 megawatt pump storage, which is expected in 1 year time, they will be full-fledged going to operate it. Of course, it has faced many challenges because of contractual issues, supply issue, some challenges, their search system, search subsystem design. So challenges are bound to come in the pump storage, but nowadays what is happening, we are more prepared. Secondly, the earlier the pump storage development was not time bound, now not being demanded. Now there is a demand from renewable industry as well as a demand from the government. So, and the guidelines and the policy framework is also going to support. So I hope these initiatives will serve the purpose of the development of the pump storage, and finally the country will be benefited in terms of long-term strategy of the storage, which is required for the country and for the net zero requirement by 2070.
So
I
thank you,
think
Mr.
thank
Tripathi.
you.
Yeah, yeah. So I think we are bang on time. So 4 minutes past. Maybe with your kind permission, both of you, I'll hand it over to Ala, and Ala, over to you if any questions we have.
Yes, thank you so much. That has been an incredibly informative and impactful discussion. And I believe the things that were discussed today have resonated quite well with our audience, and the proof is there in the long list of questions that I have for you. So I'll just start screening them.
Yeah. So what is the EdgeJet grade ancillary market likely to be traded on power exchange? How much time? What is EdgeJet? EdgeJet is India or somebody else? And see, in India, just to let you know, in India, the ancillary market, which is tertiary ancillary service, tertiary reserve, TRAS, is already market based now. Okay, that was announced in the CRCAS regulations last year, and it has now been already put in place. Very slowly, in the next 1 year or two, we believe that the secondary reserve ancillary services will also be market based on the power exchange. So you can go to IEX website, which is the wholesale power market exchange in India, and you can see, though the volumes might be very low on the TRAS dam or AS dam as it is called, but it will be there. And soon it is also going to be on a real time market also. So TRAS RTM is also there in place. I think Mr. Tripathi, if you
Yes,
can
yes,
take. Yeah.
yes, yes. Yes, I think the question regarding does India have capability to manufacture reversible turbine required for PSP? Yes, it has got capability. Now BHL is doing some, I mean, collaboration to establish the manufacturing of the generator, turbine generator especially, which is reversible. And of course, we want capacity of more than 250 megawatt in our country. So up to 250 megawatt they want to develop. But of course, at present, all are being supplied by the foreign vendors. But interestingly, the Make in India complaint, and whenever we are putting this condition in our tender, certainly people, if volume is there, they will be going to establish here. Otherwise, it is available. BHL is going to establish.
What is the power wheeling scenario in northern region or Delhi NCR region? Any reference, please? So, if you are talking about the power scenario in the NCR and the Delhi region, you can refer to, say, for example, for Delhi, you can refer to Delhi SLDC website. You'll get an insight as to what is the demand, what is the supply, which all generators are supplying, how much from market, how much from long term, how much for short term. Everything is there in the implemented schedule. If you're talking about the transmission capacity, the loading, etc., ATC, TTC, you can refer to NRLDC web page, CTU web page, which is CTUIL India, CTUI India, and you'll talk about, you will get to know about the real-time loading of the transmission lines, which form the backbone of the northern region load dispatch, as well as Delhi NCR region. So both these places, you'll find enough information. What is the anticipated LCOS of PSP rupees per kilowatt hour? Again, I'm not in favor of rupees per kilowatt hour, but Mr.
Yes, yes,
Tripathi, would you like to talk about
yes,
it?
yes. I think we are not also in favor of declaring in terms of rupees per kilowatt hour, but the storage cost, that is cost of storage. If I deduct, because as you told it during our deliberation, that the input power is normally being tied up with the whoever is going to take my power. So that's why if you discard the input power cost, the cost is coming around 5 rupees, 4 rupees 95 paisa per kilowatt hour delivered.
Yeah, so that is with 1.5 cycles operation in a day. So
Yes, one and a half hour.
1.5 cycles. Yeah. Is it right that the application of PSP storage be likely to be only FTM rather than being BTM purpose? Yes, because behind the meter, if I say front of the meter and behind the meter, so PSP can never be behind the meter.
Yes,
Okay, so PSPs are geographically located in a way it is connected to the grid. Whereas when you talk about behind the meter, that means meter of the consumer, end consumer. So end consumer is not there unless and until you define a consumer who is located in such a hilly terrain where PSP is there behind the meter. That is very difficult. So PSP will always be a front of the meter, a utility scale, grid connected, and not unlike battery storage. Battery storage can be located co-located with the demand centers, whereas these are all very geographically specific locations where PSPs can be installed.
correct. Very truly told, the pump storage can be FTM only. BTM is may not be possible in stages because of the geographical condition, water availability of water, and the site.
So, what is the mechanism for recycling of batteries after the lifespan of the batteries? Yeah, very good question. So, see, Mr. Tripathi talked about the circular economy. So, in India, though we haven't reached that stage, but globally, the secondary mining has already become very lucrative industry. So, to answer your query, hydrometallurgy and pyrometallurgy are two very widely used techniques to recover lithium, nickel, and cadmium from the black mass which is left out after you discard the batteries and from the anodes and the cathodes basically. So they estimate, the US department, the Department of Energy estimates that up to 90 to 95% of these three precious metals can be recovered from a used battery. Now, the rest of the components mainly remain are, say, steel enclosure, maybe some plastics, and the electrolyte. So they also can be reused somewhere else for this one. But before you do a recycling of the battery, there is a repurposing and reuse also there. For example, electric vehicle batteries can be repurposed for stationary usage. And after everything has been utilized, then only you go for recycling. So this is going to be a very major industry. So in India also there are few companies which I know they have started this process, especially for the EV batteries. You want to add anything, Mr. Tripathi and Mr. Anil?
No, no. I think you have rightly explained regarding. Already, I have raised the concern during our discussion about
Yes.
the recycling and this. I think you can
Sodium
answer.
and yeah, sorry. Please go ahead, Mr. Tripathi.
No, no. You answer.
Okay, so sodium and potassium ion batteries are promising or not. See, it all depends upon the TRL level. So technology readiness level, as I say. So anything which is TRL level 8 and 9 is commercially viable and deployable. But sodium and potassium ion, though they have shown some kind of promise and potential, unfortunately they are still at TRL level 4, 5, or even
Mm.
maximum 6. So there are certain laboratory tests going on. Some pilots are also going on, but they have not gained that commercial status. But yes, as for the literatures available and the results of the pilots being undertaken outside the country, outside India, we do feel that they would have potential, because these are all more abundant elements in the Earth's cluster compared to nickel or cobalt.
Okay,
So that's about it with all the questions that we have.
very good.
Yeah. So would you like to give any further closing remarks, sir?
No, no, I think the discussion that we have tried our best to give if finally the objective conclusion that storage is very, very necessity of the hour, but there are challenges associated with the development of the storage system in our country. Policy guideline and the clarity it is coming up, but more and more initiatives are required, and most important is the fund flow to the storage system that is required, and that is to be managed uh, along with the renewable integration with the our electricity means requirement. As we are proceeding towards 8 to 9% growth in the energy, the requirement of a storage is also going to increase in this manner. So more and more technological options, because more now the storage, suddenly the role or responsibility of the inventors, that is innovation in the storage, is very much required. Maybe gravity storage, like we are working on very small storage system from our discarded boiler. We are using the steam storage space so that we can use it whenever there is no required. So many innovations are required. Chemist, already I have told about the chemical means research in the chemistry, chemical engineering is required to development of the storage. So this was all from my side. I think hope you have enjoyed the panel along with the panelist. It was very smooth, very friendly, and I think we have tried to share, disseminate whatever we have learned and it has come in our mind from our perspective. It, there was no information from the internet, no information from our company. It was all our own deliberation based upon the topics that has been given, and virtually it was an experience sharing session. Thank you.
Thank you, Mr. Tripathi. So I don't have something to add further to it. So I enjoyed thoroughly and hope same for all the audience here. And over to you, Ala and Mr. Anelia.
Yeah, so thank you so much. I enjoyed the discussion and learned a couple of things from you guys. So I'll just read quote what you guys have shared in the entire discussion. There are four things which I feel are important in terms of battery storage or any technology which is going to be there. The first is the innovation and R&D. How well we are going to do in this particular domain. Then economies of scale, as we could see that there is a peak in demand of stationary batteries as well as the mobility batteries. So definitely the economies of scale will help to reduce the battery prices. The third is the financial innovation, as we could see that the OPEX and capex model in renewables project, we could also see these kind of financial model which will be coming, and I think to some extent the a lot of investment will happen into this particular segment also. And the last but not the least, that the brighter and the clearer the policy will be there from government, that will help companies to have a long-term plan and long-term vision to build the ecosystem over here in India. And I think with this all, we will be here, we will be able to generate a lot of employment within the India, and I think then we could see the growth in this particular segment in India. Thank you. Thank you so much.
Thank you so much,
Thank
sir.
you. I think,
Thank
Alan, anything left?
Yes. No, sir, nothing left. It's just
Okay.
been an honor attending, hosting you all here for this
Okay.
impactful session. I would like to
Okay.
thank our audience and, of course, our esteemed speakers, you all. And with this, we have come to the end of our event. A very special mention to you all, Mr. Tripathi, Mr. Ranjan, and Mr. Anand. It has been quite an impactful session. And a big shout out to our attendees for joining us today as well. We promise you all to come back soon with more such events, and the floor is now open for networking. Thank you all.
Okay.
Thank you. Thank you. Bye.
Thank you. Thank you.
Thank you.
Bye. Bye.